This lesson will cover characteristics of polynomials. A monomial is a polynomial, and a monomial either is a number, a variable, or a product of number and variables. So you can multiply numbers and variables together. The variables must have only positive whole number exponents. Recall, whole numbers are 0, 1, 2, 3. They won't have fractions, decimals, or negatives. Some examples of monomials. I could have just a number, so say 5. I could have just a letter, maybe x. Or I can have numbers and letters multiplied together, so maybe negative 7x squared y. Notice my exponents on my variables are whole numbers. I have a 2 here, and a 1 would be here if I put a number in the exponent. The number that you multiply outside can be negative. It could be a fraction, and it could be a decimal, as long as it's a number and not in the exponent. A polynomial is the sum of one or more monomials. Poly means many, and it is a group that will include the monomials, binomials, and trinomials, and then higher ones as well. So an example of a polynomial might be x cubed plus 3xy squared minus 7y plus 2. That would be an example of a polynomial. I have 1, 2, 3, 4 monomials listed here. I have 4 terms. A polynomial or binomial is a polynomial with 2 terms, and terms are separated by plus or minus. So an example might be xy plus 5, or maybe x cubed yz minus 3a. Those are both examples of binomials. It doesn't matter how many letters you have. This is a monomial because they're all multiplied together. I know I started a new term because I have a minus sign, so 3a is my second term. So a binomial has 2 terms. A trinomial is going to have 3 terms, and remember, terms are separated by pluses and minuses. So maybe I have 7x squared minus 2xy plus 3. That would be an example of a trinomial. The degree of a monomial is the sum of the exponents of the variable. So if I just have a number, like 5, I don't have any variables. So there are 0 variables. The degree of this is 0. If I have something like 2x, my exponent on this is 1, so the degree of this is 1. And maybe I have negative 9x cubed y squared. Notice these are all multiplied together. So you'll add your exponents, 3 plus 2, which gives you 5. So the degree of this one is 5. If you have a polynomial, instead of 1 term, you have more than 1 term. You'll have to look at each term separately and look at the degrees. So suppose I have 5x to the 6th, y to the 4th, minus x cubed y to the 8th, plus 12y to the 5th, z to the 5th. The degree, if you add these, is 10. So my first one has a degree of 10. My second term, if you add those, that's 11. And then my last one, if you add those exponents, you'll have a degree of 10. So between 10, 11, and 10, my highest one is 11. So the degree of this polynomial is 11. So you look at the monomial degrees separately. So look at each term. If you have 3 monomials, added or subtracted here. And then you'll pick the one that has the highest exponent when they're added together. Okay, now we're going to look and determine if something is a polynomial or not. If it is a polynomial, we're going to give the name, and if it's not, we'll have to explain why. I have variables here with a whole number exponent. I have a number, and variables all have whole number exponents. They are added together. So this is a polynomial. And specifically, it is 2 terms, so it's a binomial. On the next one, everything is multiplied together. And all my variables have whole number exponents. So this is a polynomial. And the name for this polynomial, there's one term because I don't have any pluses or minuses. So this is a monomial. On your next one, 3 is multiplied with x to the negative 4. However, my variable has a negative exponent. So this is not a polynomial. And that's because you have an exponent that is not a whole number. And I think D is on the next page, so I'm going to go ahead and just finish F, G, and H, and we'll go back and get the missing ones. On F here, I have 7 to the x, and notice my variable is in the exponent. It's not a whole number, so this is not a polynomial. And that's because the exponent is a variable, not a whole number. On G, I have x squared, y, and negative 2. So all my variables have whole number exponents. So this is a polynomial. Terms are separated by plus and minus. So this is my first term. I got a plus. Y is my second term. Got a minus. My third term is negative 2. So this is a trinomial. When you have a radical or a square root, in this case, I could write this as x to the 1/2. So whenever you have a radical, square root, cube root, third root, whatever radical, if you have a radical, this is not going to be a polynomial. A radical means you would not have a whole number exponent. Started to go off my page there. I'll give you a moment to finish getting that down. Okay, next page. This is still a continuation of number 1. It kind of, when I printed, went on to the next page. For D, I have 3 over x. And this is not a polynomial. In order to have a polynomial, the numbers have to be multiplied. So you divided by a variable, not multiplied. You divided by a variable. On E, negative 12. That's just a number, and I can have negative numbers. I just can't have a variable that has an exponent that's negative. So this is a polynomial. And there's one term, so it's a monomial. On my next example, I have x divided by 3. I could write this as 1/3 times x. Notice I didn't divide by a variable. So this is just a number multiplied with a variable, so this is a polynomial. Specifically, it would be a monomial. And this last one, I have y plus square root of 5. Now I said you couldn't have a radical with a variable because that meant the variable had an exponent that was not a whole number. However, this is not a variable. Square root of 5 is just a number. So since it's a number here and not a letter, this is a polynomial. And there are 2 terms because I have a plus sign. So this would be a binomial. Let's look at the degree. Remember, you have to look at each term, and the highest one is going to be your degree. So my highest exponent here is 5, so the degree of this is 5. On this one, I have 8. I have no variables, so the degree of this is 0. And let's look at each of these separately. This first term has a degree of 3. My next term has a degree of 0. 9x to the 5th has a degree of 5. And if I add my exponents here, that has a degree of 6. So the highest one there is 6. So that is the degree of that polynomial. For example, 3. I'm going to write these in ascending. So ascending means going up. So you're going to go smallest numbers of x's to the highest ones. And we're looking at the exponents. Negative 7 doesn't have any x's, so that's going to be my first one. Cross it off as I go. I have x squared here. That's my next smallest one. So plus 8x squared. My next smallest one is the 4x cubed. And then the minus 3x to the 5th. So no x's, 2 x's, 3, and 5. We're looking at the exponents. So this is x times x. I have 2 x's multiplied together. For descending, that means going down. And I gave you the same polynomial, so you're just going to have to write that one backwards. For number 5, you'll want to use a calculator. You're going to plug in 4 for my x. So you're going to type 10 times 4 cubed minus 33 times 4 squared plus 23 times 4 plus 6. And that's going to give you 210. And on the next one, I think I'm going to show you how to work that one with the calculator. So you have 10. You need to put your numbers in parentheses. So I'm going to plug in negative 1 for that polynomial expression here. And let's do this on the calculator. So I'm going to type 10, and then in parentheses I'm going to put negative 1. And to get the exponent key, I'm going to use this little caret if you have a graphing calculator. If you have a scientific calculator, you might have a caret, or you may have a key that says x to the y. I'm going to write that here. So you might want to look and see if you have a caret, a key that looks like x to the y. Sometimes they do it as y to the x, or a caret. So one of those is going to be your exponent. So see if you have that on your calculator. So I'm going to use a caret key. So cubed, and then minus 33, and then in parentheses negative 1 squared, plus 23 parenthesis negative 1, and plus 6. And I get negative 60. I'm going to try that. And we are done with the notes.